In our galaxy, there are planets that have no star. A 2021 analysis of microlensing data suggested there may be more of them than stars themselves. Most of them are smaller than Jupiter. A significant fraction may be Earth-sized, and they are drifting through interstellar space in complete darkness, with no way for us to see them directly. A rogue planet is a planet-mass object that is not gravitationally bound to a star. It can form in two ways. Either it formed inside a young planetary system and was later ejected, kicked out by gravitational interactions with another planet or by a close stellar encounter, or it formed on its own, directly from a collapsing fragment of an interstellar gas cloud, like a star does, but without enough mass to ignite fusion. Both pathways are predicted by theory. Both are now supported by observation. The ejection pathway is mechanically well understood. In a young planetary system, gravitational interactions between giant planets, what astronomers call dynamical scattering, routinely throw smaller bodies onto unbound trajectories. Our own solar system is thought to have ejected several ice giants during its first few 100 million years. The number of planets in our outer Oort cloud may be much larger than the number we have cataloged in the inner system.
What is new is the recognition that this process, repeated across every young star system in the galaxy for 10 billion years, leaves behind a population of free-floating worlds. They do not vanish, they drift. The independent formation pathway is more recent. In the 2000s, observations of young star clusters revealed objects with planetary masses, a few times Jupiter or less, that did not appear to be associated with any host star. They had infrared signatures consistent with young, warm planetary atmospheres, but no orbital companion. The label free-floating planet entered the literature. By 2010, the first statistical hint of a much larger population came from MOA, a Japanese-led microlensing collaboration in New Zealand. Their preliminary analysis suggested that Jupiter-mass free-floating planets might be nearly twice as common as main-sequence stars in the galaxy. That number was contested. It was preliminary. It was based on a few dozen events. The 2021 paper changed the conversation. The only way to detect a starless planet is through its gravity, and the only practical method at galactic scale is gravitational microlensing. The principle is simple. If a foreground object, a planet, a brown dwarf, a black hole, passes between you and a more distant background star, its gravity bends the light of the background star around it. The result is a temporary brightening of the background star. The duration of the brightening tells you the mass of the foreground object. Heavier objects produce longer events. A stellar mass object produces a brightening that lasts tens of days. A Jupiter mass planet produces one that lasts a few days. An Earth mass planet produces one that lasts hours. The Optical Gravitational Lensing Experiment, OGLE, is a survey based in Warsaw that has been monitoring tens of millions of stars in the galactic bulge since 1992. Over 30 years, it has logged thousands of microlensing events of every duration. Sorting through them statistically tells you the underlying population of unseen objects. In 2021, Przemek Mróz and collaborators published the most thorough analysis yet in Nature Astronomy. They focused on the shortest microlensing events, those lasting less than a day, which are produced by Earth mass and below objects.
After accounting for the survey's detection efficiency and the distribution of background stars, they extrapolated a galaxy-wide population. The number they got was that free-floating planets of terrestrial mass and below could outnumber main-sequence stars in the Milky Way by a factor of several. Some interpretations of the same data place the total in the trillions for objects above one Earth mass. The uncertainty bars are wide, but the lower bound alone Already more rogue planets than stars would mean a complete revision of what we thought was the dominant planetary population. The forthcoming Nancy Grace Roman Space Telescope, launching in the late 2020s, is designed to expand on exactly this measurement. Its survey will be 100 times more sensitive to short-duration microlensing events. Within a few years of operation, it should produce a definitive census of the galactic rogue planet population, down to lunar masses. If the 2021 numbers hold, the galaxy is much more crowded with dark worlds than with bright ones.
Statistically, our solar system has been visited many times, not by hypothetical aliens, by passing rogue planets, drifting through the local stellar neighborhood at velocities of tens of kilometers per second. The encounter rate is calculable from the local stellar density and the relative motion of the Sun through the galaxy. For objects in the size range of Mars to Jupiter, the rate of close approaches within several light years of the Sun over the 4.5 billion year history of the solar system is significant. Within 1 light year, less frequent. Within the planetary region of the solar system, very rare, but not zero. The closest known stellar approach in the past million years is Schultz's star, a small binary system that passed within roughly 0.8 light years of the Sun around 70,000 years ago. Its trajectory placed it deep inside the Oort cloud, the spherical reservoir of icy bodies surrounding the solar system. Models suggest the encounter perturbed some of those bodies, sending them on slow inward trajectories that may take millions of years to arrive as long-period comets.
A rogue planet on a similar trajectory would do the same thing. Worse, because a planet is more massive than Schultz's star's faintest component, the perturbations would be larger. A close pass through the inner Oort cloud could destabilize a measurable fraction of the cometary population. Earth would see an elevated rate of long-period comets for millions of years after the encounter. Most would miss. Some would not. The good news is that the time between such encounters is vastly longer than the time we have spent watching the sky. The bad news is that we would not see one coming until it was already inside the planetary region. Rogue planets emit no light. Their thermal signature, even at close range, is below the detection threshold of any current infrared survey. The earliest warning would come from microlensing, a background star momentarily brightening because of a foreground gravitational lens we did not know was there. By then, the planet would already be inside the system. This is the part of the story that the 2021 microlensing result quietly changed. The encounter rate calculations of 20 years ago assumed a small, free-floating planet population dominated by ejected gas giants. The new numbers, if they hold, imply a vastly larger population of smaller worlds and a correspondingly higher rate of close cosmic visits. We have not been visited in recorded history, but the galaxy is crowded, and most of what is out there is not lit up.
Next video. There is a gravitational anomaly 220 million light-years from us, pulling our entire galaxy along with half the local supercluster toward a single point. We have only just begun to map what is on the other side.